Usually when you sit down to build a jigsaw puzzle, you have the box right in front of you.
Right. You look at the picture on the cover, you dump out the pieces, and you know exactly what you're trying to build.
Exactly. Like the blue sky goes at the top, the straight edges form the border. I mean, there is a clear master plan right from the start.
But paleontology totally strips that luxury away. I mean, you aren't just missing the box.
Yeah.
You're operating in an environment where, geologic time has scattered the pieces, eroded half of them to dust, and secretly mixed in fragments from, like, 3 completely different puzzles across the exact same quarry.
That is such a perfect way to put it.
Yeah.
And, well, for this 4th deep dive in our special Dinosaur Stories series, we are wading into that exact chaotic reality. We're looking at one of the most recognizable, yet honestly persistently misunderstood creatures ever to walk the Earth.
The Stegosaurus.
Yes, the Stegosaurus.
Yeah.
And to do this, we are pulling from a massive stack of research today. We've got everything from high-stakes Sotheby's auction news, the brutal history of the 19th century bone wars, breakthrough histology studies from the journal PLOS One, and even some, really highly technical, community-driven debates from Reddit.
Yeah, and the overarching mission here really is to strip away that pop culture caricature. We want to move past the sluggish, belly-dragging monster of old cinema.
Right, the plastic toy version we all grew up with.
Exactly. We want to reconstruct the real, living, breathing, and incredibly complex animal that dominated the late Jurassic period. Because honestly, synthesizing these sources reveals a creature far more specialized than early science could have possibly anticipated.
Totally. And to appreciate our modern understanding of the Stegosaurus, we kind of have to look at the spectacular failures of its initial discovery.
Oh, they are spectacular.
I mean, they are hilariously off base.
Oh.
So it all starts in 1877 with paleontologist O.C. Marsh. And this is right during the height of the infamous Bone Wars.
Right, and the context there is crucial. Marsh was locked in this bitter, financially ruinous rivalry with Edward Drinker Cope.
Yeah, they hated each other.
They really did. And they were both just racing to dig up, name, and publish new species as fast as humanly possible. I mean, often using dynamite to excavate sites and rushing their field notes. It was wild.
And that intense pressure bred some pretty spectacular inaccuracies. So Marsh receives these fragmented, massive bones from Colorado, and he names the creature Stegosaurus, which translates to roof lizard.
Yeah, roof lizard. Because, well, he evaluated those massive flat bony plates, and he was looking at an enormous turtle-like aquatic reptile.
An aquatic reptile.
Yes. He hypothesized that the plates laid flat across the animal's back, overlapping like shingles on a roof to form a protective shell.
Okay, let's unpack this for a second, because the rush of the Bone Wars led to one of my favorite historical blunders in all of our sources.
Oh, the teeth.
The teeth. Yes. So Marsh documented these strange cylindrical teeth scattered among the Stegosaurus fossils. And because he was forcing this animal into his preconceived puzzle box, he just couldn't figure out where the teeth went.
He was trying to force pieces from the wrong box.
Exactly. So he ended up classifying them as dermal spines. He literally assumed the Stegosaurus had tiny quills sticking out of its skin.
Which is so funny in hindsight, because it took years for subsequent excavations to untangle that specific mess. Those cylindrical teeth actually belong to a completely different animal.
A Diplodocus, right?
Yeah, a long-necked Diplodocus, or maybe an Apatosaurus, that just happened to die and fossilize in the exact same quarry. So Marsh was quite literally trying to assemble a Stegosaurus using the facial anatomy of a sauropod.
Which is just incredible. But even after the scientific community realized they were dealing with a terrestrial dinosaur, the physical reconstruction was still heavily flawed for a long time.
Oh, absolutely. For decades, museums mounted the Stegosaurus as this incredibly thin, sprawling lizard that basically just crawled through the mud.
Right. But, and I love this detail from the Reddit discussions we looked at, if you look at the taphonomy of those early digs, that thin misconception came from a fundamental misunderstanding of the rock itself.
Yeah, the fossilized hips they initially recovered had been crushed flat, like millions of years of geological pressure just pancaked them.
Right, and paleontologists were initially interpreting compressed rock as, true biological width.
Yeah, which is a massive error. When correctly reconstructed from uncrushed specimens, we see an animal built like an industrial-grade freezer.
An industrial-grade freezer. I love that image.
It's accurate. It was incredibly robust, sporting this exceptionally wide rib cage. And the limb proportions further complicate its silhouette. I mean, the front legs were significantly shorter than the massive hind legs.
So it had this really weird posture.
Very weird. It forced the head incredibly low to the ground for browsing, while hoisting the hips and that heavy tail high up into the air.
So if you're listening, I want you to visualize encountering this thing. You are looking at a heavily muscled, tank-like animal up to 8.2 meters long, browsing on low ferns, just far more robust and intimidating than early scientists ever imagined.
Definitely. But, having this massive freezer-shaped body creates a fascinating biological problem. And it's one that actually led to the most pervasive myth in all of dinosaur lore.
Oh, we have to talk about the second brain.
We have to, because if you grew up reading paleontology books, you almost certainly heard that the Stegosaurus was so neurologically deficient, it required a second brain located in its butt just to operate its back legs.
The infamous posterior brain case. I mean, the myth stems from a very real anatomical puzzle, right?
Yeah.
The Stegosaurus had an extraordinarily tiny skull,
Right, housing a brain that weighed roughly 80 grams.
which is comparable to a modern dog.
Exactly. A dog's brain tasked with piloting a 5-ton body. And in 1881, Marsh discovered a massive cavity in the vertebrae situated directly over the dinosaur's hips.
And this neural canal expansion was, 20 times larger than the actual cranial cavity?
Yes. So, facing a tiny head and a massive hip cavity, 19th century science just jumped straight to the dual processor theory.
Right. They thought it was literally a second brain.
Mm-hmm.
But modern biology paints a totally different picture.
A completely different picture. No dinosaur possessed a second brain. That hip cavity is now understood to house what's called a glycogen body.
And modern birds have very similar structures, actually.
They do. It's essentially a tissue mass used for storing energy-rich compounds. The causality here is crucial. This cavity did not house a localized nerve cluster directing deep thought.
It wasn't doing math back there.
No math. The glycogen body was a metabolic mechanism, moving a 5-ton chassis, specifically managing the violent, rapid deployments of its massive hind legs and tail, requires immense, instantaneous energy dumps.
So what does this all mean? It's not a dual-core processor like people thought. It's more like a localized battery pack or like a dedicated graphics card strictly installed to power that heavy tail.
That is a much more accurate framework. It was a localized power supply for extreme physical output. And honestly, we also need to reevaluate the intelligence of the animal itself.
Yeah, because we looked at the encephalization quotient, the EQ.
Right, the predicted brain mass relative to body mass.
Yeah.
And the Stegosaurus falls perfectly within the normal range for reptiles.
It seems so unfair that pop culture paints them as the ultimate dimwits of the Jurassic, especially when the massive sauropods, the long necks, possessed far smaller brains relative to their sheer mass.
Yeah, the Stegosaurus was adequately equipped for its specific evolutionary niche. It was doing what worked, and that niche clearly involved heavy combat.
Which brings us perfectly to the output of that massive metabolic battery pack. We have to talk about the phagomizer.
Oh, the phagomizer. The scientific adoption of that term is such a rare instance of sheer paleontology humor.
It really is. For those who don't know, Gary Larson coined the word phagomizer in a Far Side comic strip. He drew a caveman pointing to the tail spikes and claiming they were named after the late Vag Simmons.
And the scientific community just embraced it. It literally became the official anatomical term for the spiked tail configuration.
Which is amazing.
Yeah.
But, jokes aside, the phagomizer was a brutally efficient weapon. The tail possessed 4 spear-like spikes, not 8, as Marsh once hypothesized, but 4.
Right, projecting horizontally outward. And the biomechanical evidence of their use is just staggering.
Yeah, tell them about the trauma rates, because this blew my mind.
So nearly 10% of all known Stegosaurus tail spikes exhibit signs of bone trauma. That indicates frequent, high-impact use. They weren't just for show.
Right, and the most compelling evidence of its kinetic power comes from an Allosaurus fossil. Paleontologists recovered an Allosaurus pubis bone that had been completely pierced by a Stegosaurus tail spike.
Completely pierced. The anatomical positioning requires the Stegosaurus to have swung its tail with enough rotational torque and sheer muscular force to punch solid keratin and bone straight through the dense hip bone of an apex predator.
And the detail that truly cements the reality of that interaction is the pathology of the wound itself.
Yeah, the pierced Allosaurus bone showed extensive signs of healing and infection.
Meaning the predator survived the initial catastrophic stabbing. It lived with that horrible wound for an extended period.
Exactly. The Stegosaurus wasn't just, swatting away nuisances. It was inflicting massive structural damage.
So with the tail firmly established as this devastating practical defense mechanism, we kind of have to evaluate the animal's most iconic feature, the plates.
The dorsal plates, yes.
Mm.
For over a century, the assumption was straightforward. They were mechanical armor.
Right. But biomechanically, that armor theory collapses almost immediately, doesn't it?
It really does. First, the plate stood vertically along the spine. That leaves the animal's entire lateral flanks, which is the most accessible target for an Allosaurus, completely unprotected.
Yeah, it's like wearing a helmet but no chest plate. And second, the plates themselves were not solid shields.
Right. They were highly vascularized. They were filled with internal piping for blood vessels, making them relatively fragile.
Which is what led to the dominant theory of the 1970s, the thermoregulation debate.
Yeah, so wind tunnel tests in 1976 suggested the plates acted as giant biological radiators. The hypothesis proposed that the animal would flush blood into the plates and stand perpendicular to the wind to cool down.
Or face sideways to the sun to rapidly warm its massive body, like solar panels.
Exactly. But later studies like Farlow's 2010 update and Maine's 2005 work really argue against this. The comparative anatomy tears a huge hole in the radiator theory.
Because of Kentrosaurus, right?
Right. Look at Kentrosaurus, a very close relative within the Stegosauria clade. It possessed narrow spikes all the way down its back and survived the exact same climatic conditions perfectly fine without any specialized cooling plates.
Plus, the external covering of the plates fundamentally alters how they would even function.
Exactly. The bone core was indeed vascularized to support rapid growth, but the exterior was encased in a thick keratin sheath, like a bird's beak or a cow's horn.
And keratin acts as a powerful insulator.
Right. Wrapping a highly vascularized bone in a dense layer of keratin severely dampens any significant heat exchange with the surrounding environment. It effectively rules out thermoregulation as their primary evolutionary driver.
Okay, so if they aren't armor and they aren't radiators, what's fascinating here is the transition of scientific thought. Keratin provides a brilliant medium for holding vivid, bright pigmentation.
Yes. The scientific consensus has heavily shifted from viewing these plates as purely mechanical to understanding them as highly visual, display-oriented structures.
Right. And if a species is investing that much biological energy into growing massive, visually striking structures that serve no defensive or thermoregulatory purpose, who exactly are they displaying to?
Well, the driving force is almost always intraspecies communication, which leads us directly into this groundbreaking 2015 study published in PLOS One by researcher Evan Thomas Sayita.
I loved reading the study. It's just a masterclass in modern paleontological method.
It really is. So Sayita focused on a specific species, Stegosaurus majosi, excavated from the JRDI 5ES quarry in Montana, and he isolated a startling morphological variation in the dorsal plates across the specimens.
Basically, he found that they clustered into two completely distinct shapes with no intermediate overlap.
Right. One variation was wide and oval, possessing like 45% more surface area. The other was tall, narrow, and far more pointed.
Okay, here's where it gets really interesting.
Yeah.
Because playing devil's advocate, how do we know this isn't just a herd of mixed species, or maybe just adults and babies?
Well, to declare this a definitive biological trait, Sayita had to systematically dismantle every alternative hypothesis. The ontogenetic one, the age question, is the most obvious. Are we just looking at juveniles whose plates haven't widened yet?
And this is where the histology comes in, the bone slicing.
Yes. Researchers took incredibly thin cross-sections of both the tall and the wide plates to examine the internal bone structure under polarized light.
They were looking for lines of arrested growth, right?
Exactly. Lags. They function very similarly to tree rings. The histology revealed mature, highly vascularized internal structures and tightly packed lags at the outer edges in both plate morphotypes.
Meaning they were both fully grown.
Right. The presence of those tight lines indicates that somatic growth had ceased. Both the tall plates and the wide plates belong to fully grown, sexually mature individuals. Age was conclusively ruled out.
Wow. Okay, so what about the ecological challenge? How do we know a river didn't just wash two completely different species of stegosaur into the same geographic depression?
For that, they relied on the taphonomy of the quarry, basically how they were buried. The mudstone horizon showed no signs of high-energy water transport.
Right, there were no bite marks, no shed predator teeth, no drag marks suggesting scavengers have pulled disparate carcasses into a pile.
Exactly. These animals died simultaneously and were buried in the exact same static environment. They lived, traveled, and perished together as a cohesive herd of a single species.
So having eliminated age discrepancies and multi-species mixing, The evidence squarely points to sexual dimorphism.
Yes. All other explanations ruled out. This is some of the first solid, rigorous evidence of sexual dimorphism in a non-avian dinosaur.
And the researchers concluded that the massive, wide plates, the ones boasting 45% more surface area, likely belong to the males.
Right. They were acting as highly visible, vividly colored billboards optimized for female mate choice.
While the females, freed from the biological burden of maintaining those massive display structures, retained the tall, narrow plates, which, served as slightly more practical, prickly predator deterrents.
It entirely recontextualizes their environment. I mean, ask yourself to visualize this. Imagine looking out at a Jurassic landscape and actually being able to tell a male Stegosaurus from a female from a mile away just by looking at the shapes of the billboards on their backs.
They were highly social herd animals engaged in complex visual signaling. It's just beautiful. And this incredible biology in that iconic silhouette hasn't just captivated 19th century paleontologists. It continues to have a massive grip on our modern culture and economy.
Oh, absolutely. The Stegosaurus commands a totally unique level of human affection.
Yeah, I found some great pop culture facts. Did you know the Stegosaurus is the official state fossil of Colorado, purely because a class of fourth graders campaigned for it in 1982?
I did read that. It's such a great detail.
Right, and the only reason it appeared in Steven Spielberg's The Lost World, Jurassic Park, is that thousands of children wrote letters demanding to see their favorite dinosaur on screen. He wasn't even going to include it originally.
That intense cultural footprint translates into staggering financial valuations, too.
Oh, yeah. Let's bring in that recent Guardian article about the Sotheby's auction.
Right. So in July 2024, a remarkably preserved massive Stegosaurus specimen nicknamed Apex, measuring 3.4 meters tall and 8.2 meters long, went up for auction.
And it sold to an anonymous American buyer for a staggering $44.6 million.
$44.6 million. It shattered the record for the most valuable fossil ever sold at auction.
It is wild to think about a $34 million price tag for an animal that vanished from the earth millions of years ago. And honestly, the timeline of that disappearance requires a serious mental adjustment.
Oh, the timescales are mind-bending.
Yeah, this is a fact from the Reddit sources that just broke my brain. The Stegosaurus lived in the late Jurassic, right? Roughly 155 to 145 million years ago.
Yes.
But the T-Rex evolved at the very end of the Cretaceous period, roughly 68 million years ago. That means the T-Rex is actually closer in time to US right now than the T-Rex was to the Stegosaurus.
It's so hard to process. The Stegosaurus was already an ancient, fossilized mystery beneath the dirt when the T-Rex was walking the earth.
Exactly. So we've covered some incredible ground today.
We really have.
We started with O.C. Marsh rushing through the Bone Wars, misidentifying a terrestrial titan as a flat aquatic roof lizard with a fake second brain. We dismantled the myths of the sluggish reptile to reveal an industrial-scale powerhouse swinging a deadly tail. And we explored how modern histology has illuminated a vibrant social herd dynamic where males strutted around displaying massive carrots and billboards.
And if we connect this to the bigger picture, it just perfectly shows how science is an ever-evolving narrative. Every new CT scan or, microscopically sliced bone or excavated quarry rewrites the story you thought we knew. The narrative is constantly sharpening.
Absolutely. And I want to leave you with a final thought, a quiet detail buried in the auction records for Apex. That $44 million fossil.
Oh, the pathology report.
Yeah. The records note that Apex showed clear evidence of advanced arthritis in its joints. Think about that for a second. We tend to view dinosaurs as indestructible movie monsters or static, perfect museum displays. But Apex was a living, aging animal. It walked the earth long enough to get stiff, aching joints. It carried those massive plates and survived in a harsh world until its cartilage degraded and its bones literally wore down.
That's a really humbling perspective.
It is. Next time you look at a fossil, ask yourself, what quiet individual struggles of aging and survival are frozen forever in that stone?